हेलो गाइस, आज हम लोग बात करेंगे वी विल टॉक अबाउट दी स्पार्क यूआई. ओके, I have never seen any such videos where anybody explain how the Spark UI works. Okay, so I have multiple examples. Okay, I am creating this series to make you understand that how the Spark UI looks like and what things we need to check um, for the running jobs. Okay, so let's start with the Databricks. In Databricks, as you can see, we have 15.3 GB memory with 2 cores. Okay, so basically at the end we will usually get 15.3 GB memory with 8 cores. Okay, in the Databricks, and we are using Scala 2.12 and Spark 3.3.2. okay, these are the both the latest versions. Okay, and this is for Python, but we are not using Python, we are using Scala. Okay, so now if we see this one, are you able to see you are able to see my screen, right? Yeah. So if you look at this, I have this thing. If you understand about the memory, okay, how the Spark allocate the memories, I'll show you in the Spark UI. Okay, so starting with as I said, it has 15 GB 2 cores, but when you see in the UI, it gives you the 8 cores. Okay, maybe I'll keep it as 9 cores. So one we allocate as to this this yarn manager, and 1 GB to the yarn manager. Okay, so this memory and core will be given to the yarn memory to work. So this is nothing but the cluster manager who will going to take some memory and core. So now we will going to have 14 GB with 8 cores. Okay, because we have 8 cores. Okay, for the Spark executor. So we know that we have the unified memory. Unified memory is split into two ways: storage and the execution memory. Okay, so now we will talk about the memory overhead. In the memory overhead, we will get maximum of 384 MB or 0.1% of the total memory. So total memory is this one, and it will be 10%, you will say. Okay, so 10% will be 0.1 into this one. So which is the maximum? This is the maximum, 1433.6. okay, we are taking it as 1434 MB. Now as I said, we have the executor memory, which is unified memory. Okay, so this is a unified memory, as I said, storage plus execution. So total memory after giving the some memory to the overhead, so we will get the Spark memory minus overhead, which is overhead memory is 1434 MB and total memory is this much. So finally we will get 12902 MB for the executor memory. Okay, this is what we call the JVM memory. Okay, this is what we call the JVM memory to run. So unified memory is storage plus execution. So there is a Spark fraction. If you see my other videos, I have explained the memory architecture. So 60% of the executor memory, unified memory will become 60% of the executor memory, which is the JVM memory. So 60% of executor memory will become 0.6 into, so this one will be our unified memory, and unified memory between storage and execution is split into 50-50%. So at the end we will going to have 3.87 MB for storage and 3.87 for the execution. Okay, I'll show you this memory, okay, as a storage memory in the Spark UI. Next thing is the user memory, which is non-storage memory. User memory is 40% of the executor memory, because 60% is allocated to the executor memory and the rest will be to the user memory. So it will come across 5160.8 MB. Okay, so let me show you whatever we have discussed here in the UI. Okay, so let's execute this first. I'll tell you what this means. So let me quickly run this method. Okay, Now I'll run this. Okay, so here I am creating a Spark. I am reading one file, CSV file, okay, sample data, and I am calling that method which I have written above, okay, and df.show. So if you see, so it's still running. Okay, so meanwhile we can see what we have in the method. Okay, cget method. So here what I am doing is I want to show the partitions, okay, partition and what is there in the partition. Okay, so because I will be doing the group by, I will be doing the repartitioning, so that's the reason I have created one method which will going to show you the content of the partition. I'll share it with you, all the notebook. Okay, at the end you can see that in the my YouTube description section you will get that. So okay, so I'll calculate the size of the file, okay, then the partition size of that file. So what happened is, when we have original file, okay, original file, I'll have, let's say, x GB of data, x MB of data. Now when it partition that data, okay, the size decreases. Why? Because they drop the metadata of the file. Okay, when it create the partitions, it drop the metadata of that file. I'll show you that as well. And here I am creating the directory file. Okay, why? Because here I want to put my output file, okay, in this location, file store table test partition data.txt. So with this one we will going to have multiple partitions. Okay, I'm overwriting it, I'm putting it the entire content of the file, and check the actual size of the disk, right? So I am checking that the size of the file, and here read the entire content to file to ensure we display it, and I am displaying the whole content of that file, of that partition file. Okay, so let's see if it works. Yeah, so it ran. Okay, let's go back to the before that. You see we have 334 bytes of file. Okay, original file sample data.csv is of 334 bytes, but when it created the partitions, these size decreases because the metadata get dropped. Okay, so you see this in partition 0 we have all the data. Okay, we have all the data. So this is partition.data.txt. Again we have 334 bytes, but in the partitions, in the partition we are having 286 byte. Okay, so this is the internal of the Spark ecosystem, right? So we know that Spark create the chunks of data, okay, before writing into the memory. So that's why when it create the partition, the size become 286 MB. Okay, so you can see the whole data here. Okay, so let's quickly go to the Spark UI. I'll go step by step. Okay, so first see how many executors it ran. So there is only one executor that ran. Okay, you can see it's completed. Okay, only one driver with it took 2 seconds, and let's see how many cores it ran if we are able to see it here. Yeah, let's see, let's go to the storage. Okay, don't know what happened. Let me click on that again. Okay, okay, now you can see that we have let me do this here. Okay, so now we have one executors, and let's see the number of this one execute. Let's go back to the executor tab. Okay, yeah, so initially we were in the job section, Now we are going to the executor. So in the executor you can see the storage memory is 3.9 MB. Okay, this is what we have discussed with the unified memory. So unified memory is storage plus execution. So storage is 50/50, storage and execution is almost 50/50. So 3.9 is allotted to the storage memory and 3.9 is allotted to the executor memory. Okay, and now you can see that we have the 8 cores. Okay, total active is 1 because we have only one executor. Okay, which is the driver, and we can take the thread dumps as well. Okay, so here you will going to see how the thread behaves. Okay, it's how many number of threads executed and the rest of them are waiting. Okay, so you can get that idea. And most important thing is, now let's go back to the SQL data frame. Okay, so this is one of the best tab where you can get all the information of the job. Okay, so if you see at the right side we are having that job IDs. Okay, so job ID is 3 and 0, and let's go back here. So I'll show you. If you click on that job tag, okay, let's see how many number of jobs has been created for this one. Okay, I'll show you. First we will see it here, then we will see how many jobs has been created. So unless there won't be any action, okay, the Spark will going to create a single job. Okay, so here we are doing nothing. So if you see it here, spark.read, right, we are having these two infer schema. So for this one and then reading, so this will going to have two jobs, 1 and 2. Then dev.show is another job. Okay, and for the CSV you will see going to see two. So let's go back to the Spark UI in the job section. Okay, so in 0 and 1, okay, you are seeing the reading CSV file. Okay, and the other jobs as well, it is going to read only. Okay, reading CSV file into data frame. So what is happened here, in this is combined. Okay, and this is also combined. First is reading the metadata and the other two is reading the actual file. Okay, so if you see the reading metadata took, reading metadata will always going to take some time. Okay, more time than the actual running job. Okay, so if you see this one, if I click on this, so in the data frame, I'll show you, not this tab because it will going to come in the stages. Before going back to the stages, I'll show you in the SQL data frame tab. Okay, so if you go back to the SQL data frame tab, you can see job 3 and 0, which is reading the file only. Okay, so if you click on the 0th one, okay, I'm expanding everything. Yeah, so this is what I'm talking about. So initially I'll tell you what are the things that we need to consider: shuffle write and shuffle read. Okay, so this happened when we do the shuffling. When the shuffling happens, okay, so it dumps all the small files, and it will show you the actual size of the splitted data that's been written. Okay, shuffle data. So size of the shuffle data will come here. Okay, now what it did is it added the filter. Okay, so the filter here it has added is that the field, okay, the values, whatever the values that we have should not be null. Okay, should be greater than 0. So this is the AQE, which usually run in Spark 3, it optimize the job automatically. Okay, and if you see estimated size of the row in all the column is 20 bytes. So with one row, I'll show you with this one. If I click on let's say, or I'll go back here. Okay, so each row is 20 byte. Okay, each row, how many, I mean, if you see this data, so each row is 20 byte. This is also 20 byte, this is also 20 byte. Okay, so this is what it is talking about. And file sorting by size, time, okay, leave that. Okay, so sample data size, which is our sample data, is 256 byte. Okay, is 256 byte that we have read. And if you see here, this is all the partition that data. Okay, this is all the partition data, approximately 286 or 256 byte it read. Okay, so here you can see 256 byte. That's the actual size of the file in partition, while partition. So size of the file is 256 byte. Okay, and largest file size, this is all you don't need to see. The next thing is that we need to see the physical plan. Okay, so this is the actual plan. Okay, this is the process and this is the final output. Okay, so let's see the final output. What it did, it just scanned the file, it filtered. Okay, filter, that is second, and then it collected the whole data. So first thing is this one is scanning the text. Okay, location was in memory because it put all the file in the memory. Okay, sample data.csv, and what is the size of that file is 256 byte. Okay, in partition 0. Then it applied the filter. So value is nothing but your all the values. Okay, combined values, so all the values, this one. Okay, it trimmed that and checked the length should be greater than 0. Okay, then it filtered out all the non-null values. Then it collect the limit. Okay, and here we will get all the data. Okay, so this is the physical plan, and yeah, that's it. Okay, and first you need to see how many number of jobs it has created. It has created 4 jobs, right, as we have seen there. Right, so it has created the 4 jobs. And if you click on any of the job, let's say I'm clicking on 0, net is taking some time to load the data. Okay, so if you see the stage, let's go back to the stage. In the jobs, in the next section we have stages. Okay, so in the stages we have 4 stages. Okay, for 4 job IDs we have 4 stages. Here it's not doing nothing but reading that file. Okay, so let's click on any one of the stages. Let's say the first one. Okay, so this is the so this tab will going to show you the stage by stage data, how it performed. Okay, so I'll select all. So it read that file, okay, converted to the map partition RDDs. Other thing is that you need to see is, So there I don't think you need to see anything here. Okay, so let's go back to the other stage ID. Okay, so in the other stage ID you can see the deserialized. So first it scan the file, then it deserialize that file, because initially it has created the partitions. Now that partition has been deserialized and then converted to the partitions again, okay, for reading, right? So here on heap and off heap memory is 2.2 GB or 282.7 MB. Okay, so here we will, so if we keep the on heap and off heap memory, reduce that from the executor, we will going to get the exact memory. Okay, so here you can see how many off heap and on heap memory is allocated. We can increase and decrease the size. Okay, let's go back to the other stage quickly. Similarly it deserialized and it created the map partition with index. Okay, in next video we will understand what does all means. I'm just showing you here only. Okay, so this is nothing but reading the file. We'll talk about the fair schedule pools, okay, in the next section. Okay, so how many number of scheduling mode we have. Okay, so let's meet in the next video. Thank you.